Hello everyone. Welcome to the series on Advanced Database Management System. My name is Dr. Niti Mathur and I'm your online faculty for the subject. In the previous session, we had talked about the query processing and we understood that SQL or structured query language is used for resolving the queries, and it is basically used to extract the exact data that the researcher or the analyst is looking for. So in this session, we are going to talk about these queries in detail, and also we are going to talk about the operation that is performed on these queries in order to get the accurate or the actual result. So in this particular session, we are going to talk about the relational algebra as well. So basically, we are going to discuss how we can convert the SQL queries into relational database and get the result by combining the two, that is SQL queries and relational database, and then getting the actual result that we are looking for. So let's get started. By the end of this session, you will be able to understand the procedure of converting these SQL queries into relational algebra. So let us understand what exactly is SQL and what is the relational algebra. So when we talk about SQL, it is also known as SQL or structured query language. It is basically a standardized language used for interacting with the relational databases. So in the previous session, we had talked about the insurance companies having lot of database and lot of data. So basically, they are dealing with big data because a lot of transactions are taking place in different branches in a particular city, then in a state, then a country, or if the insurance company is global, then again the database is huge. So here, if the sales manager wants to find out how much was the sale on a particular day, so they are going to extract the data from all the branches and then combine this data. So basically, relational algebra does this work of joining the data, or if there is a specific data that the sales manager is looking for. Suppose if it is a combined data and the sales manager is looking for a data of, say, New Delhi only. So in that way, it is the condition that is put forward through query, and then the actual result is extracted and we get the desired result using the SQL and relational algebra. So relational algebra is a set of operations for manipulating the relational data. Moving further, let us understand the basic relational algebra operations. So these operations are basically categorized into projection, selection, cross product, and natural join. So when we talk about projection, it basically selects a subset of columns from a table. So here a table may be having 5, 6 columns, and here we are specifically talking about the subset of columns. So, particular cells in different columns, you may be required to join all these columns. So suppose if you want to calculate the sales of 4 centers in the month of January. So horizontally, January is represented and columns are these 4 centers. So again, subset would be joining of these specific cells. Then comes the selection. So here a condition may be put so that the data can be filtered. So here the filters of rows are based on a condition. So it considers the rows, that is the horizontal section and not the vertical one. And here basically we are working on the condition so that we can filter the data. Then comes the cross product. So as the name suggests, here two tables are joined based on all possible pairs of columns. So naturally, through SQL, you combine the rows of two different tables only when there is a possibility of pairing these two or more rows. Then comes the natural join. So here you are joining two tables based on common columns. So the difference between cross product and natural join is in cross product you work upon the rows, whereas in natural join you work upon the common columns. Again, there are few more relational algebra operations other than the four operations that we discussed. Then comes union. So basically, it combines the rows of two tables, and difference removes the rows from one table that are also in another table. So there is no duplication of work, or if it is not required, then it is easily removed using the difference operation. Then comes intersection. So it basically keeps only the rows that are column in two tables. So now we are going to talk about the different statements in relational algebra, and we are also going to discuss some of the examples related to the same so that you can understand it properly. So now we are talking about translating SQL select statement into relational algebra. So a select statement, as the name suggests, it is condition based and it is basically used to retrieve data from one or more tables. And the structure of this select statement is select column from table where condition. So here you are selecting the columns from the tables and putting the condition to it so that you can filter the data. So here now we are learning the translation of SQL select statement into relational algebra, and the steps that we follow for this task are project the selected columns. So here you are going to select the columns of the table first, and then you are going to select the rows that meet the where condition. So again you are putting the filter and the condition. If there are multiple tables, then you can join them using the appropriate join operation in relational algebra. And if necessary, you can also apply additional operations such as union, difference, intersection, depending upon how you want to manipulate the data in order to achieve the accurate result. Then comes the translation of SQL select statement into relational algebra example. So here we are going to select the name, city from customers, where country equals to USA. So we are selecting the column which is name, and we are selecting from the table customers, and where we are putting a condition country equals to USA. So this statement is translated into relational algebra through the following expression: pi name city sigma country equals to USA customer. So now here the sigma operation selects row where country equals to USA, which is the condition from the customer table. The pi operation projects the name and city column from the resulting table so that you can get the accurate result. Moving ahead, let's talk about the translation of SQL select statement with aggregate functions. So aggregation is an important task when we talk about data analysis, because here you may have to do a lot of aggregation of different data and facts and figures so that you can get the accurate result. So here aggregate function summarizes the data by groups or the entire table, which means it does the task of combination or combining. Common aggregate functions are sum, count, average represented as AVG, minimum represented as MIN, and maximum represented as max or MAX. Now to translate a select statement with aggregate function, we follow certain steps. These steps are, the first one is to group the data by appropriate columns in the table, then apply aggregate function to each group of data, and then project the desired column including the aggregate function. Now let us talk about the example of translating a select statement with sum aggregation function. So here select country, sum sales from orders grouped by country. So here we are doing the grouping. So this statement can be translated into the relational algebra expression by using the following steps. So here the first one is pi country, sum sales, gamma country orders. So here the gamma operation groups the orders table by country, and then some function calculates the total sales for each country, and the pi operation projects the country and the total sales column. So in this way you get the desired result. Now we are talking about translating SQL order by statement. So here the order by clause sorts the result of the select statement. Now here we are going to translate an order by clause by applying a sigma operation that selects rows of the table based on the sorting condition. So now let us understand this with an example. So here we are going to select the name, city from customers, order by city. So here this statement is again resolved in this query is resolved using the following steps in relational algebra expression. So pi name city sigma true customers order by city. True is because it is checking whether it is fulfilling the condition or not. Then comes the sigma operation that selects all rows from the customers table. Lastly, the order by clause sorts the results by the city column, and thus you get what you are looking for. Now we are talking about translating SQL join statement. So as the name suggests, it joins the data. So join operation combines data from multiple tables. So, depending upon the size of the business, there will be big data and thus lot of tables. So this function, this operation is very useful. So there are different types of joins again, natural join, inner join, left join, right join. So as the name suggests, it is basically natural join when you are joining two tables or more tables, inner join when you are joining the inner data of the table, left join when you are joining the left side data, right join when you are joining the right hand side data. To translate a join statement, basically you apply the appropriate join operation based on the type of join that you require. Now let us discuss one example related to translating a natural join statement. So here you are going to select the customers dot name comma orders dot product from customers join orders on customers dot id equals to orders dot customer underscore id. So again, to understand it in a simple manner, this statement is executed by using the relational algebra expression in the following manner, such as the pi customers dot name comma orders dot product is used for joining, natural join between customers and orders table or the column. And then comes the natural join operation, which is performed as a natural join between the customers and the orders table. Moving ahead, let's talk about the SQL or SQL nested queries. These are very interesting because here you are going to learn a different technique of translating these queries and getting the result. So the nested queries are basically queries within queries. So we call these as subqueries that are embedded with another query. Now to translate a nested query, first you have to translate the nested query and then the embedded query, and the embedded one is converted into the outer query. So basically you are going from inner query to outer query. Now the way SQL nested queries are translated is select from customers where ID in, select customer underscore ID from orders where product equals to laptop. So here you are going to basically find out the customer ID who opted for laptops. So this statement is again converted into the relational algebra expressions. So here the pi name is customers where ID in, and then the outer query is pi customer. So with this, we have come to an end of this session. In this session, we have talked about the procedure of converting SQL queries into relational algebra. I hope this session was interesting and you liked the examples. I'll see you soon. Thank you.